Welcome to Crash Concepts, where the economy, energy, and the environment are explored. Up next, fresh ideas and insights into the factors that are driving the world and shaping your future. Presenting information you can't afford to live without, here's Chris Martenson.
Welcome to this Peak Prosperity Podcast. I am your host, Chris Martenson, and it is November 23rd, 2016. Donald Trump is the new president-elect, and at the time of this recording, he has not yet been sworn in, but people are fearing lots of things about him and his possible actions, and among those are his views and actions on climate change. One positive so far from the Trump election is that both sides of the cultural divide in America have suddenly discovered the importance of talking with each other. Not to persuade the other side necessarily, but to at least know what the other side is thinking. And one area of great divide in the U.S. at present, at least in the political class, is the area of climate change science. Now, as with any complicated and emerging field of science, there are, of course, competing and sometimes conflicting theories, models, ideas. This interview with climate scientist Dr. Mark Cochrane is being recorded with the intention of specifically airing both the knowns and the unknowns, and most importantly, what can we expect in this next political era. So what do we know for sure, and what are the unknowns, and where is there agreement? Where is there still legitimate room for debate and additional discovery, and where is the science settled? As many of you know, Dr. Cochrane conducts climate change-related research in the United States, in Australia, Brazil, and Indonesia that explores how climate change is affecting the characteristics and impacts of wildfires on ecosystems and human societies. He is professor and senior research scientist at the Geospatial Science Center of Excellence at South Dakota State University. He holds a doctoral degree in ecology from Penn State, bachelor's in environmental engineering from MIT. Mark's Earth systems science research focuses on understanding spatial patterns, interactions, and synergisms between multiple physical and biological factors that affect ecosystems. So he's our guy. He knows climate science. He's been hosting, as it were, the longest running climate thread that we've got at Peak Prosperity. It's absolutely a treasure trove of reasoned discourse, reasoned debate, good hard science, and letting the facts fall. It's just a fantastic thread. I'd invite you to go look at that if you have a chance. Mark, welcome.
All right, thank you. Good to be back.
It's great to have you back. Now, so let's imagine we've got some listeners who are really on the fence about climate change. Let's start right at the beginning, very quickly. What do we know for sure about climate change at this point?
Well, we know for sure it's ongoing. We know for sure that we have a good part to play in it. What we don't know is exactly how fast it's going to proceed, what the actual impacts will end up being, or how we can respond.
All right. Now, within those knowns, something that's I focused on a lot too, is because this seems really straightforward, is chemistry. Chemistry is pretty easy to understand, in particular the chemistry of having carbon dioxide in the atmosphere. Some of that carbon dioxide then is dissolved back into ocean water. Little chemistry happens, creates carbonic acid, and we have ocean acidification. Is that relatively settled at this point in your mind as part of this story?
It's settled to anybody who actually understands anything about how these things work, and that should be pretty much everybody here, because it's the same thing that goes on in a bottle of beer or soda. If you increase the partial pressure of CO2 above it in that atmosphere, it gets forced into the liquid. That's the same thing we're doing with the ocean systems right now.
Now, in those ocean systems, of course, this is reasonably easy to measure. pH is one of the easiest measurements ever. Not a lot of complicated equipment involved. And from my perspective, we've had lots of reports of oyster farmers on both coasts of the United States, in Washington State, in Puget Sound, and also up in the Gulf of Maine, where they're saying the oyster fry, the larvae, are not developing because their shells are dissolving. So to me, again, is this Do oceans normally fluctuate in pH, or is this for sure something we can say this is one of the ongoing effects as you described them?
Oh yeah, this is definitely one of the ongoing effects. I mean, acidity levels have gone up by 30% in recent decades. It's off the charts for millions of years in terms of the rapidity of this. Have we had really high acid levels before? Yeah, but that was many millions of years ago, and it didn't happen overnight. So yeah, what we have is all the organisms that rely on calcium or calcium carbonate shells are going to be under increasing amounts of stress as they effectively dissolve all their, whether they're external shells or even internal systems. They're having a harder and harder time making those structures. So yeah, a lot of places we're already losing things because, and this is along the coast where you're talking about, that's a lot of carbon that was actually buried back in the 50s and 60s that's kind of washing up in those regions. So that's not even as bad as it's going to be. And there's an increasing amount of studies looking at this in various ways to try to get a handle on what's happening. There's just a study out yesterday showing that they were looking in Papua New Guinea in these areas where they have a certain amount of carbon that bubbles up from the ocean, so they can actually look at what the concentrations are going to be like, say, in 2100, and see how things will respond. And they took some coral and they put them there and just monitored how they responded. And it wasn't just a question of them dissolving or having a harder time grow. They'll fight the tide, so to speak, and they'll keep trying. But they're stressed, and what they're finding is that they get these worms that start riddling through it and actually eating it, not just dissolving it. So it's kind of a double whammy for a lot of these systems.
So yeah, stressed organisms tend not to have a lot of defenses, myself included.
Yeah, all of us, we all know this.
I know, we focus on oysters because people like to eat them, but clearly, the ocean is a very complex ecosystem, lots of food webs, and I've been reading about people who do study other things, certain types of benthic snails and other little variety of things floating around. Again, many of them with these calcium carbonate shells. They're not doing well, and we've lost a lot of phytoplankton as a broad classification, a lot of zooplankton. There's just general stresses on the oceans at this point, and it seems to be that hiking your acidity by 30% has something to do with that in many of these cases. But of course, these are complex food webs, so you can knock out one organism with slightly elevated or even massively elevated acidity, but other organisms are going to be impacted by that who may not have a direct impact. So what's the extent to which we understand that this is now happening?
Well, we know it's ongoing. We can measure it. We can see it. The question is trying to infer what will occur because of it. Now, we know we're losing the base of a lot of food chain items. Therefore, it's harder and harder for other things that aren't directly impacted to feed. We also have, a variety of other things going on for coral reefs, between the heating causing bleaching, people blowing them up in fishing efforts. So right there, we're losing the food source for about 500 million people. So we have these ongoing things, but again, we know it's bad, but we haven't been here before. We can try to project, but we really don't know how it's going to play out. There will be winners and losers as always. Right now, the only winners we know of are seagrasses and jellyfish. They'll do just fine. But everything else is the question. It'll take time to play out, but it is a major concern right now, and it's one that's not on many people's radar because it's the ocean. It's far away. It's a big thing. It's been around for a long time. Life will go on. It'll just not be the life that we're used to.
Exactly. So let's talk now. I want to get to some of the points of disagreement quickly, just to get the framing up front so we can have the rest of the conversation here. So the process is not in dispute. So the process that humans burn things and more carbon dioxide ends up in the atmosphere, not disputed. Great. Some of that carbon dioxide goes as a process, ends up in the ocean, creates higher levels or greater acidity, lower pH, higher, lower. Tricky numbers to use with pH, but greater acidity. We know that carbon dioxide as a molecule traps heat because of its characteristics, its physical characteristics. None of that's in dispute. What seems to be in dispute is what are those impacts going to be So where do we have these points of disagreement? I know, we've got models that are all over the place, as obviously very complex models. I see disagreements all the time around the temperature, actual readings. Some people throwing stuff up and saying, "Oh, this satellite says there's no heating," and wait, this says there's tons. Talk to us about really that next layer of what we can really wrap our arms around at this point.
Okay, yeah. I would dispute that the models are all over the place. They're all on one side. They're just a question of how far on that side. The disputes that you raise there are the same ones we've been dealing with for, at times, up to 50 years. They've been debunked over and over, but it's like, the goldfish coming around the bowl for a new experience every time. Yeah, so we've been dealing with the same stories over and over again, and it doesn't matter how many times you can show it's not the case, it'll be trotted out again 2 months later, as if it were a new thing. So all the questions of whether or not the measurements are showing what we think they're showing. You either have debates of, they're, placing the thermometers near parking lots or something like that. It's all been proven again and again that no, they're actually well placed. They show what's going on. Or the one that's classically used by Dr. Roy Spencer and fans of his is the UAH satellite sensor, which, it's a bit lower, but why is it a bit lower? It's because it's measuring the temperature in the upper troposphere. So it's kind of like if you were standing on Mount Everest. We don't live on Mount Everest. It is cooler up in the mountains. Anybody who goes up and down mountains knows it's cooler there, but it's still rising there as well. So what they do is they say, hey, we're comparing there to these other ones that are measuring the temperature on the ground and saying, hey, it's not as high as you say it is. It's because you're not measuring the same thing. So, I mean, all of the, how many others that are used.
Well, how about the extent of the ice, surface ice?
Yeah, I mean, the only people who dispute this are people who have never actually gone there, for one. You can show this, whether it's through pictures, satellites, or personal experience, that these are melting and melting at a faster and faster rate. The biggest concern we have, for me at least right now, is ever since about 2014, we've known that the West Antarctic ice sheet, which has about 4 or 5 meters worth of sea level, is collapsing as we speak, and it cannot be stopped at this point. The only question is, will it take decades, centuries, or millennia to happen? We cannot stop this. We got Greenland melting at unprecedented rates. Even parts of it, East Antarctica are coming off. So there's, if you look at the floating ice up in the Arctic, we can show this year after year. It's lower and lower. It never recovers to the levels it was at. Just, I think 2 or 3 days ago, we had temperatures that were 30 degrees above normal at the North Pole. So it's not a real question. I mean, people can say, oh, well, no, it's not happening, but they don't have any evidence. That's the thing that gets me, is there's no other model. There's no competing model or theory. There is only people saying, no, it isn't. It's like the Monty Python skit, for arguing. You can't reason with that. We can show again and again, and I think reasonable people have come around for the most part. I don't find the same level of dispute like when I started the thread or when I started doing things in my local paper here. I live in a red state, but I find that if you actually reasonably talk to people and don't resort to name calling, that most people will go, oh, really? And you show them evidence. Most people really would be evidence-based if they could be presented with any. But there's a whole host of people out there who don't want you to look at evidence or really consider things. Everything becomes a political argument or an ideological argument. But that's not what we see around the world. And I think, in the last few years, it's really toned down quite a bit. I think the denial, if you will, is retrenching to, it's happening, but it's not as bad as you think.
Well, now let me talk about that for a second, because there was a headline that just caught my attention. It was on November 11th, came out in a UK paper. So I'll just read the headline and the first 3 sentences. Headline is, climate change may be escalating so fast it could be game over, scientists warned. And the body of the article reads, new research by an international team of experts who looked into how the Earth's climate has reacted over nearly 800,000 years warns this could be a major underestimate, because they believe the climate is more sensitive to greenhouse gases when it is warmer. In a paper in the journal Science Advances, they said the actual range could be between 4.8 degrees Celsius to 7.4 degrees Celsius by 2100, based on one set of calculations. I'm sure you're familiar with it. First, would you concur with that? And would we ever, what does it mean based on one set of calculations?
Okay, I mean, these numbers have actually been out there. What we see, for example, we'll see things from the IPCC or other sources saying that we're going to rise by whether it's 2, 3, 4 degrees Celsius. These models are run again and again under different scenarios, different assumptions. There already are scenarios out there saying that we could warm by 6 or 7, but the chance of that happening is only maybe 4 or 5%, which still is pretty large in my book. Mm-hmm. But they aren't. What we do is we tend to report what sounds more reasonable and what is, more statistically likely. So, are there possibilities for that to happen? Yes. Are they likely? Probably not, simply because the main break on that is going to be the massive amounts of ice in Antarctica, which at present we don't have a way that we know of to break that up that quickly, say by 2100. Or if it started happening, it would, melting ice takes heat. Therefore, it would actually slow down the rate of heating. We don't have a record of anything heating that fast globally. So I would say my hope is it wouldn't happen that fast, but I cannot be certain. It could potentially, yes.
All right, but so this is I think where some of the confusion lies for people, where there's a range of things from, hey, we'll get very low warming to maybe as much as over 7 degrees, which would be, I think, help flesh this out for us. What would a 7 degrees Celsius rise actually mean?
Yeah. Well, it would mean there will be no ice anywhere on the planet, for one. Every bit of ice from Antarctica, Greenland, everywhere will be gone. That'll actually probably happen above 3 degrees Celsius. 7 would mean it would happen very quickly. So we'd have, 50 meters of sea level rise very quickly.
50 meters?
Yes. And basically, nothing anywhere on this planet, if you look out your window, nothing that is there would be there. It would have to be something different, because, we can move around on this planet and we can get into our air-conditioned or heated comfort, but everything else on the planet, it exists where the climate is amenable to it. And if you raise by 7 degrees Celsius, we're not talking about for a day, an hour, we're saying on average, that's a huge change. That's more than the change that happened from the depths of the Ice Age till today. That change in the planetary temperature is about 5, maybe 6 degrees Celsius. So if you're talking about raising another 7, you're talking about basically a different planet. Now, the only question is how fast that occurs. And this is really where the problems lie. If it were to change by 7 degrees Celsius, it'd be a huge change. If we had tens of thousands of years for it to occur, life would adjust pretty well. If it happens over 1,000 years, it's difficult. If it happens over 100 years, it's insane. Nothing is designed to adapt that quickly. So, it's going to be a free-for-all, and we'll lose a lot of species, and it will be millions of years before life readjusts. It's not going to extirpate life from the planet, but it would certainly reset the clock. It'd be kind of even worse than, say, the KT boundary when the asteroid hit and took out the dinosaurs.
Okay, well, that sounds pretty dramatic, and this is something that I've heard come up a lot. Is people saying, well, the Trump presidency has now set the country back in terms of a few things. You're talking about setting the clock of life back pretty extraordinarily. That sounds reasonably dire. So before
you're going back 30 or more million years if you did that.
Well, I've got some fossils from back then.
Yeah.
So, yeah, I never thought about it this way, but I'm wondering how many degrees Celsius difference exists between myself in Massachusetts and, say, Miami.
Yeah, it's not so much. Let's see. You're saying for what kind of life you would expect?
Yeah.
I don't know off the top of my head. I would say on average, 3 probably Celsius, but I don't know for a fact. I mean, the problem is, when we talk about these averages, it's not the way anything is experienced. Uh, we talk about it's part of the problem. It's easy to say we warm the planet by 2 degrees Celsius, and for most people, whatever, let's say 4 degrees Fahrenheit, they're going to say, well, no big deal. It came up more than that since breakfast. But it's not the way it's experienced. It's not like every day the temperature was going to go up by that amount. You can have some periods where it's very high, other periods where low. You don't have winter freezes the way you used to. You get storms. I mean, it's not just the temperature. The temperature is actually the minor part of the equation. What happens is it changes all the weather patterns, and primarily it's the way the moisture is experienced. Do you get enough moisture? So it's you either get floods, you get droughts. Even if you had the same amount or even some more rainfall than you had previously, you could be in drought because as the temperature rises, you evaporate much more quickly. So the drought stress levels increase. And everything we do on this planet from our perspective is built around moisture. All the crops that we do, how we live on this, the surface of the planet. So it's huge changes that happen with relatively small changes in average temperature of the planet.
All right. Now, Mark, I want to talk about your research then. And if you could just describe for people what you're researching. And what I'm really interested in is how long you've been doing that and whether what you've detected in terms of changes in, and pardon me if this comes out wrong, but the brief span of time you've been doing this, geologically speaking, just so people have a sense of what you're doing and what you're seeing.
Yeah, I've been doing this sort of research in one fashion or another since 1994. A lot of work in the Amazon, especially earlier on, and branching out from there to, like you'd mentioned, Australia and Indonesia, the United States, and now we got another project starting in Africa. Looking at these changes, and I mean, we talk about global change. It's not just climate change. It has to do with all the things that we as a species are doing across the planet as well. But increasingly, climate change has become more and more of an issue because we've gone from thinking it was something that could happen in the next century or two to something that we can see happening right before our eyes. I look at a variety of things. One of the main things we've been looking at recently is globally, can we say something about how fire is changing on the planet? We had a paper out in Nature Communications last year showing that across the planet, in the last 30 years, we have increased the fire danger levels across half the planet's surface considerably, so statistically significantly, and we've more than doubled the area that's under extreme long fire seasons. We have a paper that's just coming out now for the United States that shows that not only is the danger of fire going up, where that is happening, we are having both more fires and fires that burn more intensely, so they consume more fuels and are harder to control, which fits with our experience. We've been having this problem for the last few decades of having bigger and bigger fires that we have a harder and harder time controlling. Combined with that, I've also been looking at things like in Indonesia. I was there for the height of the haze crisis last year during this last El Nino, where we have huge amounts of fire happening in peat swamp forests that were drained some years ago. It's an environmental disaster of our own making, where the fire burning there doesn't just burn a forest per se, it burns the land surface because it's a giant pile of organic matter. And when it does that, it smolders and puts up all kinds of nasty stuff into the air that makes it very hard to breathe. They put over 500,000 people in the hospital. But we were able to actually measure the real emissions coming off of that. And I guess I call it a rare bit of good news, if you will, is that we were able to show that the emissions coming off of those fires were actually less than what had been estimated by the IPCC, previously. So that will make Indonesia happy. It doesn't really change the impact across the planet because we can still measure how much carbon dioxide is showing up in the atmosphere, as well as methane and carbon monoxide and a few others. But I think that kind of sums up what we're doing at the moment.
Yeah, and in terms of seeing a progression of changes, are you able to detect that yet in your research?
Oh yeah, we can show that over recent decades that we're seeing again more fire and increased conditions for fire. So there is definitely a trend ongoing, and this is one of the things I try to stress more and more is that when we were talking about stress, all the systems out there are increasingly stressed because the climate is shifting. They're in the wrong place. When they're stressed, they're more prone to any number of things, whether it's insect attack, disease, but also of fire. Now, there's one hope we have around the planet is that a lot of the carbon will be soaked up by trees and other plants that are growing, and to an extent they will be. But as we stress that system and basically everything has to be moved, what we are doing is creating a system that is changing, and a changing system will actually hold less carbon overall. So over time, we're going to actually start losing carbon off of the land surface, which means we'll have more piling up in the atmosphere.
Right, and that being one of the infamous feedback loops you're describing here.
Yes.
All right, so here's a quote that came out of that same paper that said that I just quoted earlier from the Independent newspaper, this is a Michael Mann quote, and he says, "This study does indeed support the notion that a Donald Trump presidency could be game over for the climate." That's what he wrote in an email to them. So, without commenting on whether he's correct in that assessment of the defensibility of the study's conclusions, I want to ask you this. What has any U.S. president really done so far? I mean, in terms of actual concrete policy terms, to really sway consumers and businesses towards using less fossil fuels?
Well, to date, we've done little or nothing, independent of any administration. The only one that actually tried to make a difference was Jimmy Carter, and he was drummed out of office rather quickly. Asking people to actually change what they do, or asking people to do things that will directly impact our economy, such as it is difficult. Everybody wants change, but nobody wants to change.
Mm-hmm.
I'm still waiting to see what will happen under our new president. I was encouraged just yesterday where it said he was actually rethinking his stance on climate. But I was just last week at a conference a NASA conference, and they are gearing up for a possible 25% cut in budgets, trying to plan ahead. There's other rumors out there that earth science could be cut completely. So it's unlikely, I would say. I will say this though. I mean, we haven't even talked about like the Paris Agreement, but I think the U.S. has lost any leadership capacity, at least morally speaking, around the world on this issue by being so intransigent on anything to do with the issue for decades, such that if we try to withdraw from it, I think the rest of the world's going to move on without us. It'll be, hamstrung, but it will still move forward. It won't stop because of us.
Now, this Paris Accord, if you could just give people a quick rundown on what that was and what was agreed to and the progress. The progress is the ratification progress I'm talking about, rather than any other progress at this point, I guess. So what is it and where do we stand?
Okay, yeah, I mean, it comes down to, you see the glass half empty or half full. The half full, I guess, would be that it's the first major climate agreement since the Kyoto Protocol back in 1997, whereby nations of the planet have agreed that not only do we have to cut emissions of fossil fuels, we need to make them peak soon and go down. So this isn't just about slowing down the rate of increase. This is actually about trying to get it to the point that it is decreasing. So that is good. What was amazing about it is, it starts from voluntary commitments, which people can argue about, but everybody came in with their own climate action plan, put that together with the goal of trying to keep the temperature from rising more than 2 degrees Celsius and an aspirational goal of keeping it below 1.5 degrees Celsius. But they thought even after they had an agreement signed that it would take till about 2020 or later to get ratified, because that would be in keeping with what happened with the Kyoto Protocol, which took 8 years to ratify. But instead, it took less than a year, and just this year it was ratified. In order to do that, it was necessary to get 55 countries that represented at least 55% of the global emissions to ratify this. And that happened November 4th, conveniently just before the U.S. election. So, maybe people were already seeing Trump being elected. But it has continued since then. And at this point, 193 countries have signed, 113 have ratified it, and they represent 79% of all global emissions. So even if the U.S. somehow were taken out of that equation, it would still be ratified globally. Downside of this is, unlike the Kyoto Protocol, the Paris Agreement is all voluntary. There's no legal mitigation or finance targets. So, will people do what they say they're going to do? In its defense, they have to legally provide tracking progress on how well they're keeping on with the goals that they have stated that have to be publicly declared and from an independent source. So it's not like you can say, yeah, we're doing it and not do anything and pretend you're getting somewhere. So the world will know. So there's some moral suasion that can go on, but there is no legal pressure. The plan, though, is that every 5 years, all the countries have to submit an updated plan that basically tries to build upon the momentum and actually create higher targets to reach, which is very necessary because after all the great goals of trying to stay below 2 degrees Celsius, the UN has done their own study, and to their credit, they're not trying to claim victory and move on. Their own study showed that the commitments to date would still result in warming by 2.9 to 3.4 degrees Celsius, which is way above where they're supposed to be. So they know they have to improve this quite a lot. So, I think it's a good sign that the world is starting to get serious about this issue and moving towards making a difference. But it's kind of like, I don't know, dealing with global debt. Nobody wants to actually have to pay for it or deal with it, So the actual making those changes is going to be difficult when it comes down to actually impacting the bottom line, so to speak.
Well, I agree. And so now we get down to where the rubber really hits the road in this story, which you alluded to earlier, which is everybody wants this change, but nobody wants to change. I want to talk about this because this is something obviously we talk about at Peak Prosperity a lot. I know you've got a good handle on this as well. So maybe we have a meeting of the minds or a big dose of confirmation bias on this. But we know, I believe at this point, that if you can't just step in right now, we couldn't have some benevolent dictator come in and just say, that's it, we're going to cut everybody's fossil fuel use in half, but life will continue on as before. It's just not going to happen because our economy is so wedded to this. And I believe that people will be earnest and attempting to follow the Paris Accord until such time as their economy takes a hit and they need to burn some coal to get it back in the green. That's sort of my view on this. Here's the thing that I've seen missing so far. And I've read a bunch of studies, some very well-meaning ones, very, very lengthy, where people did their best to say, here's how we move entirely to alternative energy, and here's how we do it by 2030, right? The problem I have with all of these studies is that the costs of these things are extraordinary, and they're making an assumption, which is that the economy functions reasonably well as we go from a high net energy source of energy to a lower net energy source of energy, or a more diffuse set. In your mind, is it fair to say that the disruption, the potential for disruption, economic disruption here is not really baked into this thinking yet? Well,
oh, clearly. I mean, we keep assuming everything will move along smoothly, and that doesn't, it's in all models of economics, and it's in our models of transitioning to different power sources. It's in our ideas of even how the climate will progress, because all the models assume that we will have a relatively stable climate that just kind of slowly tweaks to a different state. And that's not necessarily the way that happens either. The climate can jerk around quite considerably. We are really, poking the bear, so to speak. The climate system is chaotic, and the more we perturb it, the more chance it could jump around, unpredictably as well. But certainly in terms of trying to change the system, it is not going to be something easy around the margins with nobody noticing it happen, kind of a thing. And it doesn't matter if we're talking about that, or even there was a study just out earlier this year talking about like crops. We have new crops that we're trying to breed and create that will deal with different climates that are coming. But even if you can breed these things, it takes decades to get them out in use in the different places. And the climate is changing so fast that you cannot keep that system up and running optimally. So, we're going to be losing out in a lot of those processes. So, we're going to have to make changes.
Yeah, and I guess the part that I'm surprised at I would say the lack of sophistication in this conversation, which I see all the time, and it's sort of my shorthand for it is, oh, but Chris, electric cars are really coming along, and I'm baffled, Mark, because I'm just like, well, next time you take a drive, please just count. And note all the electric cars you see. And unless you're in California or in a couple of urban centers, you're going to be either at zero or some fraction less than 1% on that story. So there's just an enormous gap between where we are and where we think we need to be. But I guess, the thing that really I want to begin to raise the conversation around is this. I think it's shortchanging ourselves to have this view put out that basically says, hey, listen, we can have our cake and we can heat it too. We're going to dial back fossil fuels and we're still going to have growing economic output. I just think I think it's a disservice to the conversation to just say, oh, that'll happen, because it's clearly humans have never had to go from our current position back down the curve of energy from a more concentrated to a less concentrated. Not that we can't do it, but oh my goodness, what a mistake it would be to say, well, we went from wood to coal, little disruption, and then we went from coal to oil. A couple of buggy whip manufacturers lost their job, but man, everything was better. Like, I don't think people appreciate the capital cost, the commitment that would be required to move in a really substantive way away from fossil fuels towards something else, whatever that mix of things that other thing is. That's the first thing. I guess I have a follow-on to that, but it feels to me like there's a very large, very realistic conversation that needs to be had there. Is it happening anywhere you're aware of?
No.
All right.
Bottom line, I think you're right. Exactly. There's basically, we can see, hey, we could do this. It's out there. It's possible theoretically without any thought of how we get from point A to point B. And this is what I do with my studies as well, is, we can say where all the trees want to be, but nobody thinks about what happens in between from where they are to where they want to get to. So it's the same thing with our energy systems. Yes, we might be able to do these things, but nobody really does the hard work of calculating the resources, the energy, the time, and what happens to the people and the economy in the middle. So I think part of that is the wishful thinking. We try not to dwell too much on pain and suffering, and nobody can sell that really well either.
Yeah, well, so that's part one of this, is that have the cake and eat it two piece. And I just think that we've got to have some serious conversations around that, because to me, it's people do much better when they're given the truth. That's why the crash course did well. It was a lot of context. I'm not going to even say it was truth, but there was a lot of context that was otherwise missing. And when they had the context, a lot of people said, "Oh, well, that makes sense." I'm not necessarily thrilled with the implications of it, but at least I have a framework that makes sense now. This has been a piece that I've read things by Jay Hansen, and not to pick on anybody, but big editorials in the New York Times or by Bill McKibben, and they keep coming to this point of saying we just need to move this direction and then things will be better. And I think there's a little gap there, which is but oh my goodness, it's this is going to require us to actively reprioritize things and really move in a new direction. And so now I guess we get to the final bit of our time here, but this gets down to the Trump piece. I think this is what's really, honestly, I can't detect that any administration so far has taken this seriously. I think people are worried that Trump, at least in his campaign rhetoric, had said, I'm going to deprioritize that a little bit. So even our lip service is going to go away. But in reality, we need to have a vision that's really comprehensive, and we need to ask people to begin to share and shoulder this burden of making this transformation, which won't be all bad. I'm not saying it's time for us all to put our hair shirts on and wallow around in misery. A lot of jobs will be created, but a lot of them will go away. It's a wrenching transformation. We will do that as a nation or as a people on this planet if we have a vision that we can get behind. And I think people were feeling maybe the vision just took a hit because of Trump. And I don't know about that yet. We'll see. He's managed to surprise me at every turn by pivoting and saying something different when he wants to. So who knows where he stands? Your thoughts on that?
Yeah, I would say, for sure. With him, we don't know what we're getting yet. Also, to some degree, even if he starts off on one track, he could change his mind pretty quickly, like happened in Russia. Why did Russia change their mind? Well, 2010, they had massive droughts and fires. They lost over 50,000 people. Why did Europe turn around in 2003? Well, they had a massive heat wave. They lost 30,000 people. We still talk about 9/11. 9/11 is a small change compared to what those places have faced. If we hit something like that in this country, people would change quite dramatically. Even as we look forward, we've got our heads in the sand. If we raise sea levels by like 4 feet, we're going to lose 2,400 miles of major roads, 246 miles of railways, airports, et cetera. Zillow did a study. If we have just 1 meter of sea level rise, we lose 1.9 million homes. Talk about infrastructure we have to build. Okay, we lose 36 cities, period. We are not even having the conversations about how we really adapt to what is happening, what's coming. At what point do we start talking about, when do we abandon a major city like Miami? How do you protect that from the sea? Right now, they've got major pumping systems trying to pump the sea back out to itself. It's sitting on porous limestone. You really can't do much with it. You can build a seawall, but the water will still come in under it. You're losing the aquifers because they're getting flooded with salt water. So at some point we're going to have to say, when do we retreat? We have areas of cities like Baltimore or Wilmington, North Carolina, that are literally nuisance flooding. They get flooded 30 times a year at this point. At what point do you flood enough that you say, maybe we shouldn't be living here?
Good questions. And a follow-up question for any of you real estate investors listening: who is buying those condos in those flood zones? I don't know. Unless your idea is that the condo will fall apart and be a derelict asset well before we have to consider moving out. Yeah, I agree with everything you said. Here we are coming up to the end of this particular podcast. But listen, this is the only thing that I think makes sense to me when somebody listening to this saying, what can I do? And I think they have to be the change they wish to see. I think people should get out in front of this ball and reduce their own carbon footprint as much as they can, understand it. Because, this voluntary simplicity today is going to be a lot better than involuntary simplicity tomorrow, if that's part of the game. And let's be clear, if the world gets serious and says, wow, we're now scared, we have to cut fossil fuel use, that is going to be extraordinarily disruptive just because we didn't give ourselves the Jimmy Carter sanctioned amount of time to do this elegantly and sort of gracefully, so we'll do it abruptly if it comes to that. In your mind, is there anything anybody can do or should be doing at this point besides, doing what they can in their own life?
Well, I'd say doing what you can in your own life is your main thing to do, and to try to get ahead of it. Just because, we're old enough. We saw the energy crises in the 70s. Well, we were able to reduce energy use quite dramatically without totally gutting the economy or anything like that. And it lasted for decades, even after the prices of gas went back down. So we could do quite a lot without necessarily just, dying of cold or heat or something like that. Mm-hmm. Put on Jimmy Carter's cardigan. We can do a lot of things. It's not enough. It's not going to change everything. That's one thing that we have to get through our heads. There is no solution. We cannot stop this. Even if we were to cut 100%, we've put in motion changes that will go on for hundreds of years. Now that's, I guess the analogy I would use is if you're in a car and you're speeding toward a bridge abutment, yeah, you're going to hit it no matter what you do, but it still makes sense to hit the brakes because you don't want to hit it at 60 miles an hour. It'd be better if you hit it at 30. So we can do things to make this less dramatic when it, as we have to deal with it. And the more you adapt in advance, the less traumatic it is if, they suddenly come out tomorrow and say, hey, we have to do it now. And just, I think part of it is we've had all this time of trying to convince our politicians to do something and everything. Now we have to do something. And to the extent that more and more of us are doing something, it becomes self-obvious that things will have to get done. Lead by example instead of waiting for somebody else to lead.
Well said. Bravo. Absolutely. And so that's really the call to action here for everybody listening is you got to lead by example, and waiting for somebody else to pick up the baton and say it's okay. Listen, we shouldn't be waiting for permission from our leadership before we do something. They never actually truly lead, they follow. So once a movement's got good purchase, they'll pick up the standard, those politicians, and carry it the last 3 feet up the hill. And that's just how it's been with every movement I've ever studied. So this is really something where I guess, it's up to us to have the appropriate context, to know that we can do things. And then my personal story, Mark, is that I've made a lot of changes in my life. I'm grateful I had the time to be able to do that. And of course, I'm grateful to have had the resources, but they haven't been that wrenching. And I've been able to, with a little bit of applied thought, really make a pretty big impact on the amount of carbon that I'm and my family are using. And it wasn't that hard. But if I had made none of these changes and suddenly had to be forced into this in a short period of time, say a year or less, it would have been wildly damaging, I think, to me.
Oh yeah, I would agree. I mean, psychologically is the biggest change. For me, one of the biggest things I did was basically get rid of the TV.
Yes.
That stops telling me I have to go buy everything and all kinds of other problems. So, but yeah, just keep doing what you can do. And you find out, your quality of life didn't go down. It's like you don't need that next little plastic thing from Walmart. You can actually live better, eat better, feel better, So it's just hard to do it all at once. Now, if you can keep adding piece by piece, and I'm always humbled by what other people are doing. I'm like, holy cow, I never thought of that. Or some people are just way out in front on this. And it really is something to see.
Well, this is, I'm going to try this. Next time somebody says, I'm really worried about climate change, and I'll say, I have it on good authority from a climate change scientist that you should get rid of your TV.
Yeah.
And see what kind of reaction I get. Listen, I'm willing to do something, but I didn't say anything. I'm not, that's too far. But I agree. Getting rid of the TV for a lot of reasons, including climate change, I can add this to my list, is a very good idea. So with that, Mark, thank you so much for your time today. If I could paraphrase, we don't know what we're getting with Trump yet. There's a little bit of wait and see. At least the world seems to be moving in the right direction. And most importantly, each one of us can decide to make this our own cause and do what we're going to do around it for climate change, maybe for other reasons as well, to become more resilient and in charge of our lives. Is that fair?
I think you said it better than I could
have. I doubt it. So with that, Mark, thank you so much for your time. Truly appreciate it.
Thanks for having me on.